Let me ask you a simple question. If modern power grids are becoming smarter, why are blackouts still happening? Why do we still see large-scale outages, even in countries with advanced technology? The answer is uncomfortable, but important. Because today's power systems, especially HVDC systems, have become too fast and too complex for humans alone to manage. And this is exactly where artificial intelligence enters the story. For decades, power systems were slow. Engineers had time to think. Operators had time to react. Failures were usually local. But that world no longer exists. Today, HVDC systems operate at millisecond timescales, continental distances, cross-border coordination, digital communication layers. HVDC is no longer just a transmission line. It is becoming the nervous system of the future grid. Traditional HVDC systems were point-to-point, one sending station, one receiving station. Modern HVDC systems are very different. Multi-terminal HVDC, modular multi-level converters, weak grid connections, fast power reversals, communication-based control. Each converter station exchanges thousands of signals every second. No human, no matter how experienced, can fully track this in real time. Let's be honest. The problem is not bad engineers. The problem is human biology. Control rooms today face alarm floods, confusing event sequences, cyber events that look like equipment failures, decisions that must be made in milliseconds. By the time an operator understands what is happening, the system may already be unstable. This is not a failure of people. It is a mismatch between human speed and machine speed. You might ask, don't we already have automation? Yes, but traditional automation is rule-based. It works when the problem is known, the scenario is expected, the logic is predefined. Cyber attacks don't follow rules. They exploit timing. They manipulate measurements. They create subtle inconsistencies. Traditional protection systems are blind to this. HVDC systems depend on fiber communication, digital protocols, remote monitoring, networked control. This brings efficiency, but also risk. A cyber attack does not need to destroy equipment. It only needs to delay a signal, modify data, confuse coordination. The result can be forced shutdowns, instability, large-scale outages. This is why HVDC and cybersecurity cannot be separated. Artificial intelligence brings something new. Not automation, but awareness. AI can detect patterns humans cannot see, identify anomalies without knowing the attack in advance, operate at machine timescales, learn from system behavior. AI doesn't replace engineers. It acts as a second brain, constantly watching, comparing, and questioning. Let's clear a myth. AI does not mean giving control to machines, removing humans from decision-making. In HVDC systems, AI's first role is early warning, decision support, situational awareness. AI tells engineers, something is wrong, and here is why. The human still decides. As HVDC systems expand into supergrids, offshore networks, cross-border infrastructure, complexity will increase. The real question is no longer, should we use AI? The real question is, how do we design AI that engineers can trust? HVDC is the future of transmission. Artificial intelligence is the future of intelligence. The future grid will not belong to one or the other, but to their integration. In the next episode, we'll explore how AI moves from monitoring to actual decision support in power systems. To read the full article, the link is in the first pinned comment. Thanks for watching. Stay safe, stay curious.